Hello everyone. Hel- Hello. Hello. Damitri. Hello. Okay, sir. Can you start? My voice and my voice is clear. My screen. Okay. So I think we should start. Okay. Okay. Thank you. Okay. My name is Samir Kumar Singh. I am PhD scholar in electrical department at IIT Ropar. I am your TA. Today we will discuss some few questions that will help you to solve the assignments of the per week assignments. Okay. Uh, this is the question number one. Here we have to find what we have a one curve. The curve is plotted between the received power and the distance. So what we have to find from the above, determine which of the given curve corresponds to highest path loss exponent among the considered cases. So we have to tell which have the highest path, which uh, which line have the highest path loss exponent. So please try. After few times, we will see the solution. Question is clear. Hello. We have to find out the highest path loss exponent. We have the five five curve, sorry, five lines. Here in x-axis we have plotted a distance, that is in meter, and the y-axis we have the received power. We have to tell the highest path loss exponent. This curve have the highest path loss exponent. Okay, now we will see the solution. Okay, just look at the first curve. First one is the blue line, and we are seeing the as we increasing the distance in respect of distance, it have the more power comparatively the red, black, yellow and green. So if we see the solution, as we moving the downwards, our n will increase because path loss exponent here and then it have a negative nature. So so here we have five times five, n1, n2, n3, n4, n5. So n5 will be the right answer, which have the highest path loss exponent. So question one is clear. Okay, guys, question one is clear. Okay, now we will see this question number two. We have the two statement, or you have to tell which statement is true. We have the four option. Please read the statements and you can answer. Statement one is the low RSSI and high SNR is an unlikely scenario, and statement two is the high RSSI and low SNR implies a bad channel scenario. Okay, the significance of the low RSSI. Basically, we have the two types of RSSI, high and low. Low RSSI is mean we are beyond the edge of the cell. High RSSI matlab high RSSI means be just near the base station. In this case, we are on the edge of the cell. And in the scenario of high RSSI, we are just below, just near the base station. So we have to tell which option is correct. If anybody know the answer, please can speak. Guys, question is clear. Please speak. Okay. Now we see the explanation of this question. After that, we will conclude which option is correct. So here I take the all four scenario. Okay. Uh, we have a table of the RSSI, receive quality, and third is the action. What we have to do, action mean. Okay. First is the high RSSI. It's mean you are just near the base station. User is just near the base station, so we have no problem. Next is the receiver quality is high. Receiving, so it's mean we have no interference. It's mean other nearest other base station are not interfering us. So it's mean we have we have to no change is required. Second case, we have the higher RSSI. It mean we are near the own base station, and the receive quality is low. It's mean we are getting high interference. Our receiver is not up to mark. So it's so in this case our channel will deviate. So to make the connection good, we have to do handoff, and it's come in the case of the intra-cell handoff. It just in this process is occur in just the cell. And the third is the low RSSI. It means we are on the edge of the cell. We are not getting the better signal. If we are in the edge of the cell, it means we are getting the high interference or the near or the on the other cells. So we are not in this case will also not get the required signal. So here we will consider the intercell hands off. And the last statement is the uh, low RSSI. It means we are at edge of the cell. And receiver quality is when a high. It means we are not getting the no interference. So it's come in the category of unlikely scenario. For this case, our channel is very good. Or for this case, our channel is very bad. So what is the statement? Statement one is the low RSSI and high SNR is the unlikely scenario, because it's statement number 4. So statement 1 is true. Similarly, statement 2 is high RSSI and low SNR implies the bad channel scenario. Yeah, it's come in the category of second. As I tell you, this make the bad channel. It's come on a good channel condition. So statement 2 is also true. It's mean our option A will be right. Guys, it's clear. Please reply. It will help. It will motivate me. Okay. Now we will take the question number 3. What is question number 3? For the hexagonal geometry, this is the valid cluster size. We have 4 options. We have to tell which is the true. Which is the valid cluster size. We make a cluster of the combination of the some cells. Please try. Okay. Okay, now we'll start. Question is the for the hexagonal geometry, which is a valid cluster size. Okay, so to check the valid cluster, we have 2 points I and j, and the combination of that formula it should be integer. That will help to find the valid cluster. So if we put the value of I is 1 and j is 1, it will come 3. It's come an integer, so it's possible. Similarly, for I is 1 2, or j and j is 2, it comes 7. So in our case, we have the option of the n is 7 and 12. So if we put the value of I is 2 and j is 1, or j is 1, I is 1, j is 2, we are getting this 7. So it can become the valid cluster. And similarly, if we put I is a 2 and j is a 2, so I is the 2, it means I square is the 4, j square is the 4, and ij is the 4. So it will come 12. So for the 7 and 12, both are the valid cluster. So what is the right option? C. Third, the option of 3 is C. Now question number 4 is display. Please read and try to answer. Guys, it's clear. Okay, question is which one of the following method can be used to improve the carrier power to interference power ratio in an interference limited system? We have to tell which improve the carrier power to interference power ratio. The first option is sectorization. Sec Second is the intracell and handover. C is the frequency hopping, and D is the all of them. Anybody got the answer? Okay. Firstly, we will see the definition of all three. After that, we will comment. Or what is asked? We have to find which improve the carrier power to interference power ratio in in an interference limited system. Okay. First, we will see the definition of sectorization. Okay. Sectorization, we will as we make the cluster. So we have the co-channel interference. We are getting the co-channel interference with our neighboring cluster. To remove this, we introduce the concept of sectorization. The motive of sectorization, it enhances the capacity of networks through reducing the co-channel interference. And similarly, it replaces the omnidirectional antennas at the base station and allow the directional antennas. The concept of directional antennas improve the signal strength and reduce the interference power. So sectorization will help us to improve the C by I ratio. Similarly, third is the intra-cell handover. Okay, intra-cell it means our cell is not changed. Whatever is happening in just in inside our cell, handover the signal when the signal power is fluctuate, tend to get the quality signal. We are doing the handoff. So in an intra-cell handover, channel is changed during the handover, but cell is not changed. This process also improve the CYI ratio. Similarly, frequency hopping. Frequency purpose of frequency hopping is to avoid interference. So these all three options are helping us to improve the carrier power to interference power ratio. So option will be the D part. Okay, next is our mathematical questions. The given is that this problem is about finding the path loss exponent of a single breakpoint path loss model. Yeah, here we are considering the breakpoint path loss model, and we have to calculate the path loss exponent. Okay, model in a communication scenario as explained in the class. The average received power reading at a various distance are tabulated below. We have a table. We have the D and received power. Okay, so what we have to calculate? What is the difference between the measured received power in dBm and the estimated received power? So we have to find the difference between the measured received power that is given, and we have to find the difference between the measured received power and the estimated received power at 400 meter. Okay, the question is clear. Hello guys, please respond. Question is clear. We have to calculate what is the difference between the measured received power and estimated received power. Please try. If anybody got the answer, can comment or speak. Here we are using the single breakpoint path loss model. So we have used the formula of the single breakpoint model. Okay, now we'll see the solution. We have to calculate? We have to calculate what is the difference between the measured received power and the estimated received power. So firstly, we will use the formula of the breakpoint model. So what is the breakpoint model? According to breakpoint model, we have to calculate the PR by using that from this formula. If we change in a dV, it will look like that. PR d break 10 and log 10 d upon d break. This is the distance. D break is the break is given and n is the exponent. We have to calculate the estimated received power. So by using that formula, we are calculating the PR. So what is the given? We have the D break is the 7. Sorry, D break is the 100, and at which point we have to calculate at D at the 400 meters. So D is the 400 meter. So D is the 400 meter. D break is the 100. Okay, or PRD break is the 0 dBm. This question are also solved by the sir in the recorded video. The same. So we have PR is a 0 dBm, D is the 400, and D break is the 100. So we will just put the value of all three. From there we will get minus 10 and log 10 base 10 4. So we can calculate a value of log 4 by calculator. It will come minus 6n. So it is the estimated power in terms of n. And here at the 400 meter we have the received power is minus 15 dBm, and our estimated power is the minus 6n. So we have to calculate difference. So we just subtracted received power with the estimated power. Received power is the minus 15 and estimated power is the minus 6n. So it will become minus 15 plus 6n. Guys, solution is clear. Please response. It is clear. Guys, if you participate, it will help you to solve the assignments. If you have any doubt, can ask. Okay, so option A is the right. Question 5. Question, we have the 4 option and A part is the right answer. Next is the question number 6. It's related to the previous questions. Here we have to use the least square method and estimate the path loss exponent. Here we will calculate the value of n by using the least square methods. Data is same. And we have to calculate the path loss exponent using the least square method. If anyone have idea, please answer. Okay, here we will use the least square method and try to calculate the path loss exponent, and data is given A. We have the several value of PRD. We calculated the PRD, and sorry, data is given. PRD is given order at 100 meter, 400 meter, 1000 meter and 2000 meter. By using that data, we have to calculate the path loss exponent by using the least square method. Okay. Firstly, we will see the what is the least square method. So what is our objective? We have to calculate the n-min path loss exponent. We have the power. So by using the least square method, we calculate the n. So by using the table, we will calculate the value of the Jn. So firstly, we will take the for the phi of 400 meter. As we solved previously, it comes a minus 6n. Similarly, we just see the how minus 6n come. By using that formula, at the 400 meter, we got the minus 6n. For the 400 meter, the estimated power is the minus 6n. By using that formula, all is same. We will only change the d. Or d break is the 100. Similarly, we calculated the PR for the 1000 meter. All is same. D break is 100 and it is 0. So it will become minus 10n. Similarly, we calculated for the 200 meter. It comes minus 13n. So we will put all these values on that function. So from there we will get that equation. We have to calculate the value of n. So what we will do, we just differentiate this equation and find the value of n. The time constant, I just write the answer. You can try on your copy. Just differentiate this equation in terms of n and equate to the 0. From there you will get the value of n. So from there we will get the value of n is 4.43. So option C is the right answer. So we have 4 options. So 4.43 is the right answer. If anybody have doubt, can he please ask. Okay. Question number 7 is displayed. Please read. Question number 7 is, consider a cellular system with hexagonal cells and a cluster size of 3. Here we are using the cluster of 3. We are making up the cluster of 3 cells. If a 123-degree sectorization is employed in a system, so how many tier 1 interference will be present in a worst case scenario? If anybody have idea, can answer this question. Here we are using the 120 degree factorization, and we have to calculate how many tier 1 interference will be present in the worst case scenario. Basically, factorization is used to improve the CYI ratio. So here we are using the 120 degree factorization. If anybody got the answer, please speak. Okay, now we'll see the solution of this question. Okay, we have this. We have cluster of the three cells. So we make the cluster. This is the cluster number 1, cluster number 2, 3. Sorry, cluster number 1, 2, 3, 4, 5, 6. These are the representing a tier 1 representation. Suppose our user is present somewhere there. Okay. So if we are using the, we will not use the 120 degree factorization. So this all neighboring clusters will interfere us. So yes, look at us. Just read this comment. At a three-cell cluster cellular system is given in the above image. Okay, C naught is the cell of the interest that serving our user P. Okay, and serve a worst case assigner user at a our user is a P. We are getting the what's in, we are getting the interference from the all the clusters. So all the cluster in the worst case scenario, all the cluster interfering these users. Only C1 is transmitting the required power, and all the 6 cells are interfering us. It is the scenario of it is the scenario of, it is the initial scenario. Now we are using the 120 degree factorization is employed at a cell. So the advantage of 120 degree factorization, these 3 cells will not interfering as, because it is radiating in the direction of this C2, C1 and C6. So there are only 3 cells. C3, C4, C5 will be interfered to the this user. So this is the advantage of the factorization. These 3 will not interfere. Only C3, C4, C5 will interfere. So what will be the option? Sorry. Huh? So what is asking? We have to tell how many tier 1 interference will be present in the worst case scenario. So answer will be B part 3. If we will use not we will not use the 120 degree factorization, then answer will be a 6. But now the answer is the 3. This is the advantage of the 120 degree factorization. Next question is displayed. Please read and try to answer. So question number 8 is the in a normalized UV coordinate system, consider 2 points with the following coordinates: point A and point B. What is the actual distance between the point A and point B if the length of each side of the hexagon is the 1.2 kilometer? So we have to calculate the actual distance between the 2 points. On the and the side of the hexagon is given as the 1.2 kilometer. Please try. Anybody got the answer? Guys, please respond. Here we have a cluster that make by the combination of the various cells. We have 2 points A and B. We have just calculated distance between the points A and B. Okay, now we will see the answer. To calculate the distance between 2 points, we just use this formula. R is the radius, that is given the 1.2 kilometer. So by just putting that value u and v, we can calculate the v. So what is the u? u1 and u2 is the 3 comma minus 3. Similarly, v is the minus 3 comma 3. v1 v2 u1 u2, and r is the 1.2 kilometer. Just put all these values in this equation. From there we can calculate the distance. So r is the 1.2. You just put the value of u1 u2 and v1 v2. From there we will get the value of d. D is the 12.47 kilometer. The answer will be the C part. Now question number 9. If a signal to interference ratio of at least 10 dB is required for a satisfactory forward channel performance of a solar system, what is the cluster size that should be used for the maximum capacity? The path loss exponent is the 3.8. We have to calculate our cluster size. What we have the requirement? At least 10 dB to get the satisfactory performance. There is an assumption. Assumption is the assume that there are 6 co-channel cells in the first layer, and all of them are the same distance from the mobile. We have just calculated the cluster size. And required SNR 10 dB. Just use the formula and put the value. Anybody got the answer? Okay, now we'll see the solution. What we have to calculate? We have to calculate the cluster size. Cluster size means n. Okay, what is the required CYI is a 10 dB, n is a 3.8. We just putting all two values, and from there we can calculate the value of n. What is CYI? CYI is the signal to interference ratio, n is the cluster size, and n is the path loss exponent. Just substitute the value and calculate. From there we can calculate the value of n. From there we are getting n is the 2.87. It's a not integer. We just choose the nearest integer value. So n will be 3. So right answer is the 3 because it is closest to the 2.8. Okay. Question 9 is given. What is question 9? Consider a cellular system consisting of a 180 user in a particular area. Each user make an average call of 1 call per hour. On average, each call lasts for the 4 minutes. What is the total offered traffic in the environment? Guys, read the question. We have to just calculate the total offered traffic, and I mention all the steps. What is given? Call arrival rate is the 1 call per hour. It means we are getting 1 call in per hour. user is the 180, and holding time is the 4 minute. We have to calculate what is the total offered traffic in branch. To solve this question, first calculate the traffic per user. After that, you can calculate the total traffic offered. If anybody got the answer, can comment. Okay. So firstly, we will calculate the first traffic per user. After that, we will go for the total traffic offered in the branch. So by using that formula, we can calculate total traffic. AU means the traffic for the per user. So it is just a multiplication of the call arrival rate and the holding time. So lambda is the one call arriving is the in per hour, and h is the 4 minutes. Call holding time is the 4. So in R it will be to 4 by 60. So total traffic for the per user is 1 into 4 by 60. AU for the one user. To calculate the total traffic, P just multiply the number of users, and total user is the 180. So we will multiply the 180 with with these terms. So 60, 180, it will come 3. So answer will be 12. Guys, question is clear. That it is the traffic for the per user, and we just multiply the total number of users. Now next question is given. Please read and try to solve. Okay, question number 11 is what is the traffic intensity per channel for a cellular system with 25 channel and a blocking probability of 5%? Here we have to calculate what is traffic intensity per channel. And given is the 25 channel and a blocking probability of the 5%. Okay, what is given? By using the 25 channel and in blocking probability is a 0.05. So we can calculate from data on using the Lance calculator. We can calculate the capacity. It will become 19.95. Okay. So we have to calculate traffic intensity per channel. So we have the total traffic is that 19.95, and number of available channels is the 25. Just put all these two values. It will come 0.798. So answer will be D part. Guys, it is clear. Okay. Question number 12 is same as the question number 11. It's similar to the same. So question number 12 is assuming use user generate 0.15 inlines of traffic. So particularly per user generate 0.15 traffics, and user are uniformly distributed over the geographical area covered by the cells. How many user can be supported for the 5% blocking probability of for the 25 number of trunk channel in a block call clear system? So here we have to calculate the number of users. The scenario is given 5% blocking probability for a 25 numbers of trunk channels. If anybody have any idea can speak. Okay, we have to calculate how many number of users with this scenario. So what is given? Okay. We have the total number of channel 25. Blocking probability is the 0.05, and given is that each user generates 0.15 in length of traffic. So after we have the traffic of the one user. So by using these two datas, we can calculate the value of the we can calculate the total traffic. So using the line calculator, we for a 25 channel 0.05 blocking probability, so it will come 19.95. So total traffic is a 19.95, and per user is using 0.05 traffic. So we have to calculate the number of users. We just divide the total traffic by the each user traffic. It is a 19.95 and it is 0.15. It will come 133. If any doubt, you can ask. So answer is the A part, 133. Okay. Next question number 13 is sorry, it is same as of 12. If question is in a ego question, if one channel is reserved for the handoff purpose, how many user can be supported? In extra is that here one channel is reserved, so how many users can be supported? So we just solve same as previously. Here we reserve the channel for the handoff is one. What we have so we now we have the channel total number of channels 24. Initially it was 25. There we reserve one channel, so we will have 24 channel. Blocking probability is same as previous. It is the 0.05, and each user generation 0.115 traffic. So here we will calculate the blocking total traffic for the 24 channels. 24 channels and 0.05 blocking capacity. It will become 19. So by using the same formula, we can calculate the total number of users. Total traffic is 19, and each user's traffic is 0.15. It will become 126. So initially it was 133, but in this question we reserved the one channel for the handoff purpose. So here we can only support the 126 channels. Okay. Next is the question number 14. Question number 14 is a consider a 7-cell reuse cellular system in which an average call lasts 2 minutes. Well, I mean it means holding time is 2 minutes, and the probability of blocking is at 2%. Assume that every subscriber makes one call per hour. Call arrival rate is the one call per hour. Assume that block channel are cleared so the blocking is described by the Reliance P distribution. If there are a total 168 traffic channel per cells and 60-degree sectorization is employed by the removing the omnidirectional antennas in the system. Here we are using the sectorization of the 60-degree. So what is the approximate reduction in the number of users per cell? Firstly, we will calculate the same way previous. After that, we will use the concept of 60-degree sectorization. We have to calculate what is the approximate reduction in the number of user cells. What is given? Call holding time 2 minutes, blocking probability is 2%, call arriving rate is one call per hour. Okay, now we will see the solution. So firstly, we will calculate the number of users for the initial condition. Okay, so okay, Using an enhanced B calculator, blocking probability is given as 2%, so it will be 0.02, and channel is the 165 channels per cell. The capacity is the 154.5 nLANs. Capacity for the per user, it is a total capacity or total traffic. We from here we will calculate the traffic for the per user. It is just the multiplication of the call arriving rate and call holding time. Call arriving rate is the one call per hour, and a call holding time is the 2 minutes. So we will calculate in the hour. It will be 2 by 60. So traffic for the per user is the 1 by 30 n. Now we will calculate the total number of users. How many users we can support with this condition. It is a just division the total traffic and per user traffic. Total traffic is the 154.5, it is given, and the per user traffic is the 1 by 30. So from this data we are getting the 4635 users per cell. Now we are using the 60-degree sectorization. So the number of channel reduced to the 28 channel per sectors. Initially it was a 165 channels per cells. Now we have the 28 channels per sector. Using the inline calculator, for the blocking probability is the 0.2, 0.0022 and 28 channels. Total capacity is the 20.15. It is a total traffic with the 60-degree sectorization. And the traffic per user is the same. So from there we can calculate total number of users supported by the 60-degree sectorization. It is coming as 6604.5 users per sector. This is data for the per sector. So we have the 6 sector. So to calculate the total number of users, we just multiply the value of the 6 with the 604. It will become 3627 users per cell. So using the initially we are supporting the 4635 users. Here we are getting the 3 where we can support the 3627 3625 users. The loss of the users, we just subscribed at the 4635 with the 3627. So it will become 1008 users per cell. Guys, if you have any doubt, you can ask. Okay. There's a theoretical question. Question number 15 is that if a handoff occurs between a 4G base station, it is called inter-rat handoff, or is true or false. Here it is a handoff is occurring is a 4G base stations. It's mean they are switching is happen between two same type of base stations. It is called the inter-rat handoff or not. Anybody know the answer? Okay. So this statement is false. Why? Just the reason. Okay. Basically, inter-rat handoff occur when the two base stations are of the different radio access. So suppose one is the 4G base station, other is the 2G. If we are doing the handoff between these two base stations, that type of the switching is called the inter-rat handoff. But here in this statement, both the base system is same. It's come in the horizontal handoff. Horizontal handoff means same rat. Rat means radio access technology. Horizontal handoff is its handoff occurring between 2G to 2G base station, 3G to 3G. But in the vertical handoff, we can switch from the 4G to 2G, 3G to 3G. So this statement is the false. Question number 16. Which is of the following is the most favorable action for the cellular system to take on a user whose RSSI is high and receive quality is low. RSSI is high mean we are just near to the base station. Receiver quality is low, it means we are getting the high interference. For this scenario, what we will do? How we maintain the quality of the users? The scenario is given: RSSI is high and receiver quality is low. It means we are near the base station. It means we are getting the high interference. We have the four option. So intra-cell handover, it may be because its condition is the we are just near the base station. So this is and we are getting interference. It's, so option A is the right. Intercell, it's come for the two different cells. So it is a wrong. Frequency hopping also you use to remove the interference. So option A and C is favorable for this statement. RSSI high and the quality is low. So option D is the right. This is the very same explanation that I explained in the previous question. So our scenario is the high RSSI and low receiver quality. So for this we will use the channel as the bed. So we will use the intra-cell handoff. Question number 17 is software handoff is a procedure related to. We have to tell which option is true. Software handoff. Inter-rat handoff, inter-sector handoff, inter-mode handoff, vertical handoff. Anybody have idea? Okay. The answer of this question is inter-sector handoff. So software handoff is related to the inter-cell handoff. As sir discussed the soft handoff, hard handoff, software handoff. So it's software handoff will come in the category of the inter-cell handoff. Question number 18 is again the mathematical questions. It is a little calculative. Question is: a mobile phone receivers operates at 2 GHz in a bandwidth of 200 kHz at 300 Kelvin and has a noise figure of the 6 dB. Receiver is present on the cell H and minimum 4 dB SNR is required for the reliable communication. Some data is given and the minimum 4 dB SNR is required for the reliable communication. Consider the log normal shadowing effect with sigma 6 dB. Given there is a maximum power constraint of the 1 milliwatt that is the base station can transmit. Find the maximum radius of the cell for the 95% coverage probability. Assume that free space part was model. And this is the given that for the value of the Q. We have to calculate the maximum radius for getting the 95% coverage in the entire cell. Okay. Here we will use the path loss, free space path loss method. The main thing is that in this question the log's normal shadowing is introduced. It is a 60. Okay. By using this data, what is given? Noise figure x 6 dB, T is the 300 Kelvin, bandwidth the 200 kilohertz, receiver operator 2 gigahertz. So calculate the receive power. Firstly, we will calculate the receive power. Receive power is the for the case of the log normal shading is the transmitted power, path loss, and log normal shading. So for that, firstly we will calculate the noise power. KTVF is given. Just putting the value, we will get at the minus 114.8 dBm. Noise floor is given the 6 dBm. Received, yeah, from by using that we calculate the received signal sensitivity, and we have the required SNR is the 4 dB, and noise power is the minus 114. So signal sensitivity is the minus 110.8 dBm. Okay. Next we will calculate the received signal power. So PT is given a 0 dBm path loss model, we are using the phase space path loss model. So the 20 log 10 4 pi d upon lambda, and our f is given the 2 into 10 is to 9. From there we calculate lambda. Lambda is a 0.15 meter, and it is given. We will put all these value there. So condition of outage: if our received signal power is the less than the receiver sensitivity, so we will give in the outage. For the coverage, our received signal power should be greater than the received sensitivity. So we'll just put all these values. Received signal power is there, and receiver sensitivity is the minus 110. Okay, by using that calculation, we are getting Q is we are getting this. What we have to get 95% coverage probability. So outage probability is the 5%. So using this data for the 5% outage, Q is equal to 1.644. So just we will put this value is the for the 5% outage, it will be to 1.644, and all is given. From there we can calculate D. So D will be the 32.5 meter. In the kilometer it will be the 1.33 kilometer. Okay. The last question of today's session. Question number 19 is: consider a user moving with a constant velocity in open area. Assuming both the transmitter and user are approximately at the same heights. Okay. Maximum Doppler shift is offset when the user moves. We have four options. We have to tell which option is true. First option is the away from the base station along the LOS path, and the second is just this reverse towards the base station along the LOS. In the both case, we are getting the LOS path in a direction perpendicular to the LOS path. And fourth option is the for both A and B. It's talking about the maximum Doppler shift when we observe the maximum Doppler shift. For this question, the answer will be A and B both, because it is away from the base station along the LOS path and getting the LOS. Similarly, towards the base station along the LOS path. So A and B will be the right answer. A and B will be right. So option D is the right. This is the explanation of this question. Doppler shift is maximum when the angle between the direction of the movement of the user and the direction of LOS received signal is 0 degree and 180 degree. By just put the value up due to cos term, cos 0 is 1 and cos 180 is 1. So here we will get the maximum Doppler shift. This is over from my side.